So while Shrikant sir is there testing what's happening with Tantric, let me quickly show you the videos that Shrikant sir quoted. So it is these videos. It goes by the playlist name, which is called Neural Network Zero to Hero. So you can find the videos there, and each video is no less than 1 hour. And the first video, or the 8 days of lectures that I've given you, or this is the 8th day, it's based on only on the first video, which is nearly 2.5 hours. So it's by Andre Karpathy. Quite intriguing videos, but it's not for beginners. It is certainly for beginners, but you have to have that kind of enthusiasm to learn. Otherwise, you will think this is something not that I can do, and you will give up just on the first 30 minutes. So if you're a person who's really interested in understanding deep learning, generative AI, these are the videos that you should watch. And recently, I think in July or August, he released another 4 hours of video on how you can build GPT-4. So those are massive videos, and the way he explains is really great. Before this video series, I remember watching his Stanford video lectures, CS231N. It was also really good, but that was dealing with abstraction. He was teaching about CNNs, etc. But this video or these series of videos are really good. If you're a person who's interested in understanding deep learning at a core level, then you should certainly watch these videos and try to mimic the code he's teaching. He's also providing some code on GitHub. You can go through that repository. But before you go through that repository, I would suggest have a Jupyter notebook open, watch his videos, and try to replicate what he's teaching. That way, you can learn. Now, how much time will each video take to understand? Though it's of 2.5 hours or 1 hour, 1.5 hour, it takes at least 1 to 2 weeks to understand what he's teaching for a reasonably good person who is well aware of the mathematical fundamentals and who is well aware of the deep learning fundamentals. So you can think that 1 hour of his video is equal to 2 weeks of learning. So you can go by that math. So this is the playlist, and my lectures are based on this video, the first one, the micrograd. Now in this video, sometimes he skips through the content completely, he copy-pastes the code. So that reasoning is what I added in addition to what he already taught. So you can watch his videos and understand what was different or what is same in what you learned so far. And from here on, you can pick it up and proceed with the other videos. Is it working now? Not yet? Yes? Okay. Which 201? Okay. Only 201 IP is working. And the student seated in the back. Is it working or no? Tantric. 201, I think it's this access point. 10.11.51.201. 202. Okay. Instances of Tantric are up, so you should be able to log in. Only front row's answer, is it? That's the rule. Alright, so since it is ready, you can just keep the practice notebook open, but we have good amount of time before you start working on the practice notebook. At least 10 to 15 minutes I will take it up for theory to sum up what all did we cover so far and what you have to expect today, because this is going to be the closing session for my lectures. The further lectures will be taken up by Anuradha ma'am. So they will be on CNN and other things. I think Shrikant sir will be giving you that complete lesson plan on how it's going to be further. So today we will be concluding this ANN training part. What we did so far was forward pass, loss function calculation, and now we have to do the updation of weights and biases. So that is pending. So that is what we'll complete today. So there's going to be one short exercise and one gigantic exercise. And is it going to be very different from what you did so far? Not really. It's going to be very similar, but we have a few, tricky part in exercise 2 where we want you to think and then implement the code. So that's the reason we'll be allocating more time for exercise 2 and slightly less time for exercise 1. And also please note that we'll be closing exercise 1 after the set time, and then we'll enable exercise 2. So make sure you follow the time constraints, keep the time constraints in mind. So coming to today's lecture, all right, so it is a quick summary or a recap of what all did we cover. On day 1, we saw the introduction to ANN. I told you how the inspiration for ANN is taken from neuroscience or the neural pathways in the human brain. And we also understood how math is involved in ANN training process. So that was all about day 1. And we explored a little bit about deep learning, the fundamentals of deep learning. I showed you the 5 steps, the 5 main steps of ANN training. Up to 5 steps is what we covered. The 6th step is what we did on day 2. And on day 1, you completed 4 exercises. And day 2, again, we had neuroscience plus mathematics a little bit. And we explored the fundamentals of deep learning again because there was a little bit of spillover. Then you implemented the binary cross entropy loss function, if you remember the exercise. So there were 5 exercises on that day as well related to derivatives and other things. So that was all about day 2. And coming to day 3, this is when we started exploring value class. And this you should remember because we were stuck with only one exercise. So, wo wala day tha. It was day 3. And then day 4, we implemented the backward method. We introduced the build topo method. We implemented that. We understood why we need to traverse a node graph from right to left and how do we calculate gradients and how do we assign the gradients. And for that, on that day, you completed 2 exercises again. Day 5, whatever you implemented on day 4, the backward and build topo, you moved it to the value class. And additionally, what you did was drawing parallels between the value class and PyTorch tensor. We understood how similar they are and how did we try mimicking the PyTorch tensors by using value class. And additionally, I showed you how the make dot method and the draw dot method we are using are similar. On that day also you completed 2 exercises on day 5. Coming to day 6, you handled the type conversions. Remember, we added 1 line of code under the implementation of d_add, d_multiplication, where we ensured that the other operand is of type value. So we were casting it to value, just to make sure that the operations work correctly. And then we implemented the neuron class and layer class on that day, and we had 2 exercises on the topics. And day 7, that was yesterday, we did a forward pass using MLP class. So on day 6, we just introduced or implemented neuron class and layer class, whereas on day 7, that is yesterday, we implemented the MLP class as well. So up to loss calculation is what we did. We did not update the weights and biases yet, so we'll be doing that today. So this is to sum up the complete 7 days of journey, plus today is what we are going to do. And if you completed all these 14 exercises plus today's exercises sincerely, then you have all the good knowledge there. If you did not do it sincerely, you just did it for doing sake, then nobody can help you. You have to help yourself. So you are all set to understand other deep learning algorithms like YOLO, or if you think of LLMs, Llama, anything else. So you have all the right terms, you have all the knowledge that is needed for you to understand those research papers, to understand those code. So you can implement them and understand in depth. So now, whenever you are prompting ChatGPT, if you get an answer from ChatGPT or a code from ChatGPT, you should think before you copy paste. So that thinking is what we wanted to put in your mind. So coming to today, so recap of all 8 days or 7 days, that's done. So kudos is there. I'll be appreciating your patience. And then there's a finale exercise that I talked about, that we'll be allocating more time for exercise 2. So I won't be talking much here. And then we'll be completing this, and then we start the gradient descent. Now the order is slightly shuffled. The reason for that is because I want to end my PPT first and then switch over to notebook. So for that I had to jumble this sequence. So kudos to all of you for sticking around for 8 days. Taliyan, taliyan. Or should we say chitkelu? So certainly I can say with a lot of confidence that you have an edge over your peers who are not here. So they are ghosted, all these seats which are vacant. You certainly have an edge over them if you attended these classes and completed the exercises with sincerity. And now, you know that deep learning is not magic. Earlier you thought, because you're working on tantric, it's going to be some kind of magic. So it's not a black box, it's not some kind of magic. Now you know it is purely math, but super complex math that you'll be dealing with, and you'll be playing with it further. And finale exercise. Now for this we'll be allocating more time, and the reason for that, it's going to be slightly lengthy. So I won't be giving you much of boilerplate code. I minimize the boilerplate code so that you can type in, implement all the code that you learned so far. Make sure that you don't do silly mistakes like the indentation errors or not calling the methods correctly. So whatever mistakes you encountered so far, that should be corrected in this exercise. And it is designed slightly to make you think. Because up to day 7, what you did was very much inclined to what I taught you in class with the live coding examples. So we have left some chunks of code where you have to think and then type. So we wanted to instill that thinking power in you. And it's not very different from what we did. It's going to be slightly different according to me. But let's see how it plays out when I open the exercise. So this again we'll discuss later. When I open the exercise 2, I'll give you a quick description of what is expected in exercise 2. Now coming to finale, finish. So my pro tip or suggestions for you is that please continue learning, continue practicing. That's the only way you can learn or achieve something in life. There's no magic involved, and you have to level up. And as a mentor, what I generally see is that you all are in some kind of comfort zone. You just don't want to get out of that for reasons well known to you. So don't compare yourself to the people around you. Compare yourselves to the people who are above you. Meaning there are many others of similar age group, right? Your friends, maybe in other colleges, or people whom you don't know at all, but who are in BTech. It could be IIITs, it could be NITs, IITs. Talking about engineering colleges in other regions, you have VIT, BITS is there, and what else? Jadavpur, KIIT. So all these colleges are there. So take a holistic picture, compare yourself, where do you stand, and then open your eyes, understand you have to level up. Please come out of that comfort zone. I don't know why you all are in that kind of complacent environment. Please come out of that. Be a little more competitive. You have to be more proactive. And for that, this is my suggestion. So firstly, you should know that you don't know everything. So we also have been through this phase where we become suddenly overconfident out of nowhere. That happens to everyone. But it's again our own responsibility to make sure that we are grounded. We should know that we don't know many things and try to learn as much as possible. So we also have been through the same phase where we suddenly think that we know everything. We are on top of the world. Don't get there. Please think that you have to learn a lot of new things. Keep yourself open to learning. Have an open mind. Grow as much as possible because it's the best phase of your life. You don't have any responsibilities, family responsibility, family pressure. I don't think it's much, right? You can take as much risk as possible. And in terms of learning, you have so much time in your hand. You don't have to dedicate time to anyone else. You can work on yourself. So please utilize this 4 years of your time. 2 years are done, but you have 2 more years. So utilize this time efficiently. And now coming back to our ANN training part, gradient descent. So quickly I'll wrap it up so that I can leave you more time to explore exercise 1 and exercise 2. Now this is going to be a very short in-class activity that you can complete along with me. After that we give you complete time for exercise 1 and 2. So coming back to what is gradient descent. So I think I revealed it, but anyway, let me ask you. We said that derivative is with respect to one variable, and gradient we understood that it is with respect to multiple variables in an equation. So my question is, whenever we calculate a gradient, and if I move my values in the direction of gradient, will my loss value increase or will it decrease? Will it increase or decrease? No, you can use ChatGPT also. Just tell me, if I update my weight based on the gradient value, will my loss value increase or decrease? Increase. And what's the reasoning that ChatGPT gives you? And do you think that's right? Loss value, does it increase or decrease? Let's say there is one weight and it has its corresponding gradient. So I increase the data value of that particular weight with respect to the gradient. Then will the loss value, overall loss value increase or decrease? You're saying decrease, okay? And there are people who are saying it's going to increase. So let's understand this clearly, what happens. So this is what you have to remember. Right? Yeah, we'll get there. Learning rate, you're using the right terms, but we'll get there. See, gradient typically point towards the direction where the loss value increases. So remember this clearly. Gradient typically points towards the direction of increase in the loss function. We said that there will be a curve and then we take a derivative. It gives us a direction where we are going towards. If I nudge the value of one variable slightly, then it gives me a direction in which I will be going next. So gradient is what we are storing that value in, and now my gradient value will tell me that if I go in this direction, the loss value increases. So that is how the gradients function. So now our target should be minimizing the loss, and for that we have to move in the direction opposite to that of the gradient. Because let's say there is a curved function. I take a gradient of W1 and it says if I step in the direction of the gradient, I move up the graph. Then my loss function also, or the loss value, increases. So now that I have the gradient and the weight value, now I have to change or depend on these two values somehow. So I'll use the gradient but move in the direction opposite of the gradient. Because gradient by itself gives me the direction of increasing the loss function or the loss value. So I will move in the direction opposite of the gradient. This has to be very clear in your mind. So again, there is one GIF file that I added here. Now what is this graph? You will come across many blogs which quote graphs of similar kind. So basically the graph that you see in 3D is a loss function. But in reality, we cannot actually represent a loss function like this because we have many variables. It is an n-dimensional space and it is not possible to actually visualize a loss function. This is a representation only for you and I to understand in a 3D space. So the graph that is there, the multicolor graph, it actually represents the loss function. And the steps that are taken down, it's like you walking down the hill. That is the gradient descent. quite literally, right? You're descending and you're using gradients for that. And why are you descending? That's because you need to arrive at the least loss value. So for that, again, global minima, local minima are the terms you might encounter. But to simplify in today's session, I will say that gradient descent means identifying a path in such a way that I get down that hill or that graph. And that graph represents a loss function. In real life, it's not possible to do a n-dimensional representation. This is purely for visual understanding that a 3D representation of a loss function is given to you. And gradient descent, meaning we are descending the loss function curve using the gradient values, updating our weights and biases. So we use the gradient values, we update the weights and biases in such a way that the overall loss decreases or becomes almost zero. So it's not possible to reach actual zero, so it almost becomes zero or close to zero. So these points have to be very clear in your mind, and there were a few here on my left. You were talking about learning rate. So looking at the graph, where do you think is the learning rate? Okay, between the stars, the distance between the stars. Yes, they were talking about learning rate. Probably we just have to include learning rate somewhere. They are right. We decide what should be my step size, because the gradient gives you the value by which I can change the weight. But how much should I change the weight? Should it be directly proportional to the gradient value, or should it be a small fraction of it? That is decided using the learning rate. Because if you see this graph, this has been tuned in such a way that we achieve the global minima. But let's say the learning rate is too high, or the step size from one step to the next step, if it's like 10 points, then you might even enter some other zone where there is no local minima or global minima at all. You end up going to some other peak position. So we have to tune this learning rate very carefully. In the code, I'll explain it to you how it works, but for now, just understand things visually. So basically, there's a hill, and your task is to get down the hill, reach the bottommost point. And for that, if you're running or taking bigger steps, you might end up reaching another hill. You have to be careful when you're descending a hill so that you reach a flat region and stop there. And for that, you need to take smaller steps, not bigger steps. If you take consistently bigger steps, probably you might miss that complete flat and the bottom portion. You might end up getting onto another peak. So learning rate is what defines how quickly you can achieve that global minima or local minima. So learning rate has to be chosen with lot of care. So that also comes under hyperparameter tuning. There are certain thumb rules that you can follow, but it is not a mandate. Many blogs or many websites suggest that how you can tune the learning rate. So they give you suggestions or pointers. Like let's say if you're using tanh function as the activation, then what should be the combination of learning rate? And if you're using sigmoid, what is the suitable combination of learning rate? So they give you suggestions, but this is not a mandatory. That combination you have to test, understand how your ANN is performing, and then set the learning rate accordingly. So this is not set as part of the gradient descent automatically. The tuning has to be done by you or whoever is designing this ANN. They have to decide a learning rate correctly. Only when you decide a good learning rate will your ANN perform properly, meaning it can reduce the overall loss. So there is something called as overstepping problem. So if you choose a too big learning rate value, then it's likely that you are overstepping the global minima or the local minima. So you have to choose an optimized learning rate, not too big, not too small. If it is too small, the problem is it will take lot of time to go to the local minima or the global minima. So if you are taking tiny steps, then it will take forever for you to climb down a hill, right? If you can imagine that way. You're climbing or descending a hill, and if you're taking very tiny steps, then it will take very long for you to reach the bottom. So your convergence or the ANN convergence will take lot of time. So these are the terms I'm emphasizing enough so that you can make a note of it, or probably just make sure that you understand these jargons or the terms clearly. So whenever if I ask you, is your ANN converging correctly? How much time does it take for an ANN to converge? What is the epoch learning rate combination that you're using? You should be able to answer. So these terms should not sound alien to you. All right, so this was a visual representation of gradient descent. So I have a quick example. We have to update the weights and biases and using the respective gradients, but you have to move in the direction opposite of the gradient. We understood that from slide 1 on gradient descent. Now for example, I have weight 1 which is holding the data 2. Its value is 2 and the gradient is 0.1. So my question is, what should be my new updated weight? W1 dot data minus learning rate into gradient. Okay, but the reasoning for that? Okay, moving in the opposite direction, so you're giving me the reason why I'm using minus. And learning rate? Okay, so to control how much we decrease the gradient, or by how much fraction should we keep stepping, right? So your friend says the formula should be W1 dot data minus learning rate into W1 dot grad. I'll show it to you on the PPT. So certainly we have to go in the direction opposite to that of the gradient. For that we introduce minus. But the actual formula should look like this. This is what he said, but I slightly changed how I represent it. So basically we take the W1 dot data and now we have to change it. So we multiply W1 dot grad with the learning rate to decide how much should be that change be. Should that change be big or should that change be small? So that is decided by the learning rate, and then I apply a negative, that is minus, because I have to move in the direction opposite to that of the gradient value. So this is the formula, important formula to update the weights and bias also. So make a note of this somewhere because I'll be discussing this in the live code session also. And now it's time to switch to our practice notebook. So give me a minute, I will make sure I switch to the screen. If one of you are facing issues with Tantric login, please report it to Shrikant sir. So finally it's working at my end too. So you can use the same notebook that we used till yesterday. So it has the updated value class. And yesterday I showed you that this is how the dependency is between the classes, MLP, layer class, neuron class and value class, and the corresponding implementation of neuron, layer and MLP. And also make sure that we have parameters here, the parameters method implemented in the practice notebook. The reason why we will need this is because we are updating the parameters today. So this method is important in MLP, in layer as well as neuron class. And this is the same code I'm using and the architecture that I want to build or the ANN I want to implement. So this is the ANN we would like to implement to keep it simple. And this is how we implemented a neural network yesterday. So we use the MLP class because this is going to initialize the layers in a neural network for us. So we started here. And then I showed you how we can create a tiny data set. We have the features stored here in X's and we have the Y's stored here in this list. Then we did a prediction using the X and Y's and then we calculated the loss function or we calculated the overall loss. So this, I would say, this is a forward pass. This is a forward pass and this is loss calculation. Next, what are we supposed to do? We have the forward pass done. Loss calculation is done. Backward, correct. But there is a thing that we need to take care of, that is resetting gradients. I'll tell you why this is important. Reset gradients and call backward. So for that, how can we reset the gradients? Parameters, yes. So we are collecting the parameters. If you remember from yesterday's class, we are collecting parameters. And where is this exactly coming from? From here. So we are composing a list of all the weights and bias because these are the variables that we can change. And then we are making sure that by calling parameters, this list is getting returned to us. So now the gradient values are entirely stored in the list of parameters. So there is a way for me to update all the parameters by iterating over each element in the parameters list. Now my goal is to reset the gradients, and for that what I'll do is, for parameter in n dot parameters, p dot grad is equal to 0.0. I will rerun my cells because the runtime got disconnected. We won't be using the draw dot method today. So forward pass, loss value, reset of gradients, and as mentioned in the comment, we are resetting the gradients and we have to call the backward. So loss dot backward. Done. And what else is pending after I call the backward? So we are resetting the gradients, and by calling the backward, we are again initializing the gradients. Nudging weights. So update is what I would like to call. Update weights and bias. For that, how do we do it? Okay. Same n dot parameters. So again, we take the same iteration step that we did here. Then I gave you the formula in the PPT. P dot data, okay, plus is equal to, yes. So learning rate, where is it? Do we have the learning rate? No, not yet. We did not define it in any of our cells. So here we define the learning rate also. Let's say it is 0.1. You can take a look at the good practices when it comes to tuning the learning rate. But for now, I choose to have a learning rate of 0.1. So now we have to update the data. So plus equal to and minus of learning rate into p dot grad. All right. So this is done. But we don't see any changes. How can we look at the changes? We did a forward pass in a neural network, we calculated the loss, then we went back, calculated the gradients, and then we also updated all the weights and bias. So what happens next? Again forward pass, yes. So also take a note of these values, these should change, and I'm using a random seed of 10 here. So earlier it gave me minus 0.5 and the loss value was 6.12. So we should see some kind of changes here. So let me do the forward pass again. So we can see that earlier it was minus 0.5, now it is changed to minus 0.6. And the loss value, I don't think there's much change. No, I did not run the cell. So 12, 13, yes. So when I rerun the loss calculation function or this cell, I see that the loss has decreased from 6 point something to 5.9. So there is a slight decrease. And again, now in the second iteration it becomes clear. When you call the loss dot backward for the first time, the gradients were initialized. But let's say we don't reset our parameters. The problem happens that we keep accumulating the gradients. So in the first pass, you assign the values of the gradients. Now, if you don't reset the values here, you keep accumulating the gradients of the second forward pass, which is not required and that is not needed. So that's the reason we need to reset our gradients before calling backward every time. That's because we have updated our weights and bias. And now when we call loss dot backward, that will be with respect to the new weights and bias. So we don't want the older gradients to be there somewhere accumulated. So that's why resetting the gradients is very important. So make sure that you reset the gradients properly. And then let's call this backward again, loss dot backward. And now let's do the update of parameters. If I go back, do the forward pass, now the values have changed slightly. Let's see what is the loss value. Earlier it was 5.9. When I rerun this, it is 5.6. Good, not bad. And similarly, I continue doing this for some more time. And then let's see what happens. I think it's taking too long for the convergence to happen because my learning rate is set to 0.1. So when you notice that the convergence is taking a lot of time or you have to keep repeating this process several times, then what you can do is, as part of hyperparameter tuning in your neural network, you can slightly change the learning rate and see how your overall network performance or learning is. So I will change my learning rate from 0.1 to 0.3. Now since I changed my learning rate, I have to restart my entire ANN training process. So I will go back here, reinitialize my neural network, X and Y remains the same. I do the fresh forward pass, this is iteration 1. Then loss value 6.1, back again, backward, parameters update, forward pass. So it is changing quickly now. Hopefully we should be descending in another probably 9 to 10 steps if we don't overstep. So let's see. Forward pass, loss calculation, call backward, update, repeat. Oh, so we overstepped. So this could be a case where we entered some other minima. So let's try again, few more steps and see before we change the tuning of learning rate. Okay, so it first went from 6.1 to 5.9. From there it went to 8 point something and then it came down to 3.9. Now let's see what's happened further. .7, so it's on a route of decreasing. So it reduced to 3.5. Is anyone getting a loss value close to 0? Not yet? Or close to 1, 2? So basically it reduced from 3.5 to 2.8. Anyway, our target is not achieving 0, but just wanted to see whether it's going to a minima or no. 3.2. So it increased again. .5. So what happens in case I set the learning rate to 1? Let's see. So you can also try this, different combinations for another 2 minutes before we start exercise 1. Anyway, this may converge, this may not converge because we are using some random set of values and it will be some unique combination of these number of iterations plus the learning rate which actually leads you to 0. And for that we need to have a lot of patience. And now since we are doing this stuff more on a manual side, that we don't have all these libraries equipped, we have a basic library there. So you need to have good for loops to do all this work for you. So I'm not using a for loop right now. So that's the reason I have to rerun my cells every time. Okay, so in this case, I would like to stop here because this is a repetitive process. This actually comes under hyperparameter tuning. If it's possible, you can identify that unique combination of learning rate and the iterations, that is number of epochs, then you will know where your model will converge properly. So we can proceed with exercise 1, and whatever you did as part of this live session right now, the live coding activity, it is more or less similar to that. I have a couple of instructions also there. So I will just go ahead, open the notebook, and you can see that notebook. To see this notebook on Tantric, don't worry about the iteration not getting 0, it doesn't matter because we are dealing only with a sample data set. So it's only for you to learn, understand how these parameters actually play a crucial role. So to give you a brief introduction to this exercise, you have to do same whatever you did during this live coding session. It is all about ANN training and calculating the gradient descent. And for simplification, as I mentioned here, the value class, neuron class, layer class, and MLP are all defined for you. So the code is there available. You have to focus only on the logic for ANN training and gradient descent. And there is a slight change that I did in the ANN architecture yesterday versus today. So take a look at what are the hidden layers, how many neurons are there in each layers, and how many layers are there. So we are importing few required libraries. Then we have the value class, which is quite lengthy now. Then we have the neuron class, layer class, MLP. And here comes the important part, or the code that you have to implement. So this is where you have to do the code changes to implement the logic for ANN training and to perform the gradient descent. So for this, what is already there? X, Y, and random seed are initialized. You don't have to modify that, but you have to complete the code for using the MLP class and to initialize the ANN. You have to apply the logic in order to train the ANN, that is whatever steps we did, the forward pass, then calculation of loss, doing a backward propagation, calculating the gradients, and then updating the weights and bias. So all these steps you have to do. And for that, how should you tune your neural network? You should be training this neural network in 50 iterations. So what I showed you in the class, I was rerunning all the cells. There was no for loop. So now I'm asking you, you have to somehow iterate and do all these steps. So this is a tiny bit of code that you have to include, but remaining everything else is there. So training iterations will be 50, and then the learning rate should be set to 0.1. And here you can see that X and Y values are defined. This is where you will write your logic. Okay?
Yeah. Anybody facing any problem with logins? Only one.
And also myself, because it's disconnecting several times, I don't know why. So where I left off the explanation, here you need to initialize the neural network and then the training logic. So I gave you the pseudo code here in this cell. So you just have to translate this pseudo code into the actual Python code. So this is to give you more guidance on how you can do the implementation. And also for you to get better at reading the pseudo code and then translating it to actual code. A little bit of exercise there. So if that is done, then your visible test cases should pass. And since most of you reported that precision is sometimes not working correctly and assertions are failing, so this time I made sure that the precision is not too high for asserting the end results. But even if you're facing issues after that, please let us know. We'd like to correct it at our end too. So that's it. If you have any questions, please feel free to ask. This is passing. If the visible test case is passing, mostly the hidden test case will also pass. 10 minutes guys, please make sure you submit this. So those whoever can see the green stars or 0 by 0, it means you completed the exercise successfully. So there is some small bug in that grading process. That's the reason you see that 0 by 0. So 5:15 we close exercise 1. Exercise 2 will not be having this issue of 0 by 0. So it's time for the second exercise. This is going to be lengthy. And there are a few things which are different from the regular flow of coding that we did so far. So what is it? I'll show you, but give me a minute. I'll open this for you, this exercise. I'll release it. So let me go to the student view, verify if I can see this exercise too. Yes, it's there. Fetch. So you can see this exercise now. I named it as finale exercise, and I want to see how fast and smart you all are. Exercise 2, guys, please fetch it. So what is different? It's again ANN implementation and training, but here's the catch. Whatever you used so far was TANH activation. Now you have to use leaky ReLU. So this is what I defined here. What is new or the tricky part? You need to use leaky ReLU instead of TANH activation. So there has to be a method leaky ReLU implemented as part of which class? Value class, correct? And leaky ReLU takes one parameter which is called alpha. So I'm saying that has to be set to 0.01. And remaining everything is same, very similar to exercise 1. Even the data set and the ANN architecture, everything is same. Only the activation function changes. And besides that, why this is lengthy is because in the value class, you have to fill in add method, multiplication, and then leaky ReLU. So I gave you a method signature for this. For leaky ReLU, you have to implement the code for it. So basically, you have to calculate the output when you apply leaky ReLU on the sum of Wx plus B. That is for the forward pass. And what else has to be implemented under this method? Neuron? No. I'm asking in the value class, under leaky ReLU, you will do a leaky ReLU of something, you will calculate, you give a output. But what else has to be done? Backward, yes. So that nested backward method also you have to implement to calculate the gradient, to accumulate the gradient, and to assign the gradient. So this has to be handled. So leaky ReLU will be a tricky portion of work for you, but if you're smart, that also won't be taking much time. And neuron class, layered class, MLP, I do not give you the code here, you have to implement it. Because I was told that you guys are getting good at copy pasting without thinking. So I want you all to think before you copy paste. So you will know while copy pasting or when you look and type, how will you miss things, right? So get good at coding from scratch. After that, everything remains same. Again, the n iterations and learning rate, I slightly changed it. I already initialized it for you and it's the same pseudocode. So that's it.
Be your FSD, and then we'll resume this activity from October 14th with a new trainer. Her name is Anuradha, and she will be covering the basics of CNN with image processing. How do you create a convolution, and how do you go step-by-step approach? Okay. So those who have submitted, one second, let me just, yeah, SRIPOOJA, do you have any follow-up? Do you want to speak or you want to have any ending? So those who have submitted, I want them to leave.
Yeah, they can start leaving, those who have submitted, but others, please make sure that this is done, right? Otherwise, you will not have the complete code with you. And what else? You can watch the playlist that Srikanth sir mentioned before we started this session. That is quite helpful. And also have these notebooks stored somewhere. So if you're watching or you plan to watch these videos later, the Karpati's videos, the Andre's videos, then you can have a reference of these notebooks. So you don't have to rewrite the code. So that's it from my side. And if you have any questions, I'm available during the PSRs also. We can discuss. And all the best, guys.